I revised it, so till how much we've learned.
Okay. So I'm going to give you a question. Very good. Keep it up with your homework. I checked it. It's all good. If you have additional any doubt, you can ask me.
Okay, sir.
Today we are going to finish this chapter. How does evaporation cause cooling?
So is that the question, or is it continuing? Because
Yes, the question is complete. How does evaporation causes cooling?
because the evaporation reduces the temperature and gives
Gives what?
it so because the evaporation when it's cooling, it reduces the temperature
See,
and the
that's
molecule.
good. I'm going to explain this. Then you are going to answer me. Okay.
Okay.
Evaporation means what? Evaporation means liquid into gas, right?
Yeah.
This is it. Liquid into gas. So let's take an example. There is a liquid. Now, evaporation will what happen? This is your water. Just wait a minute. This is your water. Now, what will happen? This water will absorb heat from the surrounding, heat energy from the surrounding, heat energy from surrounding. It will absorb heat energy from the surrounding. And what will it do? This heat energy is basically used to break the force of attraction between the water particles. This heat energy is called what it is called? Latent heat of
Of fusion.
vaporization.
Hmm.
Since it is converting itself into water vapor now, are you getting my point?
Yeah,
So this is
so
called heat,
yeah, I got
latent
it.
heat of vaporization, latent heat of vaporization. Now see what will happen when it absorbs heat from the surrounding. So what will happen? Heat is lost from the surrounding. Heat is lost from the surrounding. Yes or no?
Yes, sir.
Which causes cooling to the surrounding. Are you getting my point?
Yes, sir.
So this is the concept behind how does evaporation causes cooling. Basically, the system of particles will absorb heat from the surrounding. When it will absorb heat from the surrounding to break the bond, to break the force of attraction between the molecules or between the particles. So from the surrounding, if heat is lost, so what will happen? The temperature decreases in the surrounding and hence cooling or hence cooled it. Is that clear?
Yes, sir.
Okay, please do write this. Let me know when you are done with this.
Yes, sir. So finished.
Very good. Just wait. Okay, write a question regarding this. That is your what happens when you pour some acetone. That means basically, do you use nail polish?
Yes, sir.
So do you
The
fill?
nail polish remover. Yeah.
Yeah, yeah, on your palm. So this is chemistry. You feel cool or not?
Yeah, I feel cool. And
So
sir.
yes, yes. Sorry.
Uh, I is it become it when you pour the acetone on your palm, it becomes cool because the acid in the acetone evaporates very quickly. So it will absorb the heat and give you cooling instead.
Yes, exactly. So evaporation takes place. So what happens there? It's a very simple phenomena, just like I explained. As you know that evaporation takes place how? So it's very simple. Absorb heat from the surrounding, absorb heat from the nail surface, basically. So that's why we feel cool. Is
Yes, sir.
that clear? Okay.
Yes.
So how are you going to write it? Just wait a minute, please.
Okay.
So how you are going to write it?
We can write that the acetone has an acid in it which evaporates very quickly.
Everyone knows
So,
that acetone has acid. Acetone is basically acid, not has acid.
okay.
Okay. So see, I'm going to write either acetone, either phenol, and perfumes are volatile substance. Do you know what does volatile means? Yes or no? You are not audible. What is volatile substance?
Volatiles,
The
I'm
one
not
which
sure,
is
sir.
easily converted to vapor.
Oh,
So I'm writing this. You can see either it is not only acetone, phenol and perfumes are volatile. These all are volatile substances that evaporate when come in contact with air. Evaporation facilitated. Evaporation is facilitated facilitated as it uses energy from the palm as it uses energy from the palm. So it uses energy from the palm, which makes the palm cool. Is that clear? Hence,
yes, sir.
living a cooling effect on our palms. Very easy it is.
Sir, after acetone in the answer, what is needed?
What did you say?
In the answer you wrote after acetone, what did you write?
Phenol
His
it is.
second word.
This is no the one which I
Yeah.
erased. This is your phenol.
Okay.
Let me know when you're done with this.
Okay, sir. Sir, finish.
Very good. Right, the next question. After a hot sunny day, these questions are very important and frequently asked in the exam. People sprinkle water on the roof or open ground. What happens?
People sprinkle water on the roof or open ground because then evaporation will occur in that time, which will cause the floor and roof to have a cooling.
Very good. So how you are going to write it? It's very simple. And water is sprinkled and water is sprinkled on the roof or open ground. It evaporates because of the latent heat of vaporization. Because of the latent heat of vaporization, leaving behind a cooling effect. Isn't it true?
Yes, sir. Yes, sir.
Please do right. Let me know when you are done with this.
So
Are you done with this?
I'm on the last line, so wait 1 minute. So I finished.
Very good. Now I'm going to give you some question. It's like not the question. Basically, MCQs first. I'm going to give you some of the MCQs. Before that, why water vapor in air? How it is present. Water vapor in air. You have seen if you have a glass of water and in this, if ice is present, you know that the glass will have some water droplets. Yes or no? Outside.
Yes.
So there is always some water vapor in air or in the air around us, which we cannot see basically, which we cannot see. So how does this form? So the water vapor present in air on coming in contact with, you can see, contact with cold glass of water loses energy, loses energy. I will explain the mechanism as well, and gets converted into liquid state, which we see as water droplets. So how water droplet forms, this can be the answer. Oh, see what happens. See, this is in ice. That means basically this has a temperature 0 degrees centigrade or 1 degree centigrade or 2 degrees centigrade up to 5 degrees centigrade, right? There will be
Yeah.
some, basically the temperature will be very low when it is ice. You just take ice and put it in glass. Now the surrounding will have the room temperature is basically 25 to 30 degrees centigrade. Yes or no?
Yes, sir.
Now, what we say, the ice will absorb energy from the surrounding and it will be converted into water, right?
Yes, sir.
And here the water vapor, whatever is present here, it will also convert into water droplet, and in this way water droplet forms. Is
Yes,
that
sir.
clear?
Yes.
Please do write it. Let me know when you are done with this, Rebecca.
Okay, sir. Sir, finished.
Very good. Now, I'm going to write the difference between evaporation and boiling point. So write it difference between evaporation and boiling. So the first here is your evaporation. You already know about evaporation and boiling because we already discussed about this. So first
Yes, sir.
point I'm going to write, it takes place at all temperatures. At all temperatures. It is not fixed that it will take place at a certain temperature. It takes place at all temperatures, at any temperature. Okay. And here, when we are going to talk about boiling, it takes place only at boiling point, a certain temperature which is fixed. We talked about this.
Yes, sir.
Yes or no? The second point we can write, it causes cooling. You just know evaporation causes cooling and it
Yes.
doesn't causes cooling. When we are talking about boiling, it does not causes cause cooling. It causes heating basically. The
Yes.
third, it is surface phenomena. I already told you about this. It is surface phenomenon. That is starts from the surface. Starts from the surface. And here the third point, it is bulk phenomena. I already told you when we discussed. It is bulk phenomenon.
Yes, sir.
That is start from bulk.
So are there more points or that's it?
Yes, this is it.
Okay.
Let me know when you are done with this.
Okay, sir.
Let me know.
So I finished.
Very good. Now I'm going to give you MCQ. Which of the following represents the suitable condition for liquefaction of gases? I'm going to give you option: low temperature, low pressure, high temperature, high pressure. Low temperature, high pressure, high temperature, low pressure. What do you think?
So high pressure and low temperature and high pressure will for basically
Very good. Very good.
liquefaction
Low
of
temperature and high pressure. Very good. Which of the following energy is absorbed? Which of the following energy is absorbed during the change of state of a substance. A specific heat, latent heat, heat capacity, heat of solution.
So latent heat.
Very good. And out of these four options, basically you have only studied about latent heat, right?
No,
Latent is
yeah,
the, yeah, yeah. And
I was thinking all of them just like that, thinking
okay,
each scenario for each option.
okay, very good. If the temperature of an object is 268 Kelvin, it will be equivalent to -5 degrees centigrade plus 5 degrees centigrade, 368 degrees centigrade minus 25 degrees centigrade.
That's 268. Okay, the
Kelvin,
question.
yes. Yeah, yeah.
Okay.
K is your Kelvin.
Sir, is it -5 degrees Celsius?
Yes, it is. 273 Kelvin is equal to 0 degree centigrade, and it
Yeah,
is 5 Kelvin lesser. So you can easily do this, right?
yeah.
268 minus 273, that makes it 5 minus 5 degrees centigrade. Okay, the next question. In a crystal of potassium permanganate is placed at the bottom of water in a beaker. The water in the whole beaker turns purple on its own, even without stirring. This is an example of option A, distribution. Option B, intrusion. Option C, diffusion. Option D, diffusion.
So I'm confused on the word intrusion and effusion.
Basically, effusion is when gases comes out of a small hole.
And intrusion?
Intrusion is basically something disturb you, that is introduced. Intrusion, like now, basically in your private, like when you are studying and someone is disturbing, that is intrusion. Some
Oh,
enters. Okay.
okay. That. Okay.
Or basically in chemistry, if you're going specifically, so some particles enters abruptly or like that. Okay.
Yeah, okay. Is it distribution, sir?
What is?
The option answers the distribution.
No, see, potassium permanganate is at the bottom of water in a beaker.